when approaching this question, the first thing you want to consider is the chain rule. So if you want to find the derivative of, in terms of a, if you want to find a derivative of 1 at u, you look as to what u of x matches, which u of x matches f of g of x right here. So when you look at f of g of x is just the formula. F of g of x represents that at g of x, the derivative of g of x is going to be taken at the derivative of g of x for f and multiplied together. So I'll show you what this means. So first what you want to do is you want to find 1 on the x-axis of the graph and just trace it until you hit g. And then you want to look at the corresponding y, which would be 5. So our first value is 5. And we want to analyze the derivative at 5 for g. And if you look at the derivative here, you'll see that it goes across by 1 and down by 1, which means that the derivative is negative 1, because that's the slope. So we're doing negative 1 multiplied by the value we found from here at f. So we're going to find 5 on the x, trace it to where we meet f, and then find the slope. Now when you make a point right here, to find the slope, just look at where the point is over here and look at where the point ends over here. That will be the slope of this part of the f. And this is a negative slope, and if you look, it goes down by 1 and across by 6. So it's equals to negative 1/6. Multiply these two values together, you'll get 1/6. And that will be your answer for the first one. And then to determine whether or not it exists, well, since you found a value, it exists. The only time it doesn't exist is if your value, like if it gave you a value of 2, or not 2, if it gave a value of 3, and it wanted you to find for g, it wouldn't exist because this is a peak. Or not necessarily peak, but this is like a major turn. Same with here, because the slope here is 0, so it doesn't exist. Same as if it gave you a point that just like didn't correspond to anything on the graph, but all the points do. So I want you to try a different question. I'm going to write one on the side. I want you to evaluate at u, or at, what is this, g, or f, v of 1. So if you look, you're given this formula here. Now what's interesting about this equation is that it's flipped, right? The g goes on the outside, the f is on the inside. You're just doing the opposite of what you did last time. You're applying the same principles, but doing the exact opposite. So this time, instead of looking where it equals g, look at where 1 equals f. So if you go to 1, you trace it, the y is 2. So f of 1, and you take the derivative at 1, you go up by 2 and across by 1, has a slope of 2. You're going to multiply this by g of 1. If you look where g equals 1, it's the same value again at 5, and the slope is negative 1. So 2 times negative 1 equals negative 2, and that's your answer, g of 1. And it exists because you found an answer. There's no peaks or anything.